All right, let's get right into it. Today we're talking about some tiny, often completely ignored parts that, believe it or not, make our entire modern world run. They're like these hidden heroes in a massive network that's humming along just out of sight. And I promise, by the end of this, you're going to start seeing them everywhere.
So, let me ask you a question. What actually holds everything together? From the giant refineries that give us fuel to the processing plants that make our food safe, what is the one common, absolutely vital piece of tech that's at the heart of all of it?
Believe it or not, you're looking at the answer right now. On one side, you've got the sprawling industrial plant, just massive. And on the other, the tiny little component that makes it all work. This wild contrast in scale, from the absolutely gigantic to the incredibly small and detailed, that's exactly what we're digging into today.
Okay, to really get why these little parts are such a huge deal, we first have to understand the enormous problem they're designed to solve. Just try to picture our industrial world as having its own circulatory system, a hidden network of pipes that is constantly facing some pretty immense challenges.
And look, this isn't just, water flowing through your garden hose. We are talking about extremely corrosive chemicals, gases squeezed under thousands of pounds of pressure, and temperatures that can go from freezing cold to incredibly hot. If any single connection in this whole system fails, the result isn't just a little drip. It can be absolutely catastrophic.
So, how in the world do you manage this constant, high-stakes fight against pressure, temperature, and chemicals? Well, the solution is actually pretty elegant. It's super powerful, and it's all about making the right connection. This is where our unsung hero finally steps onto the stage.
And it's called a pipe fitting. The official definition is pretty simple, right? It's just a part that connects pipes. But what it actually does is way more important. See, a fitting is where a system is most vulnerable, and because of that, it has to be the strongest, most reliable part of the whole setup. Let's look at the three most basic jobs a fitting has to do.
First off, a system needs to go around corners. It can't always go in a straight line. For that, you've got the elbow fitting, right here. It's the most fundamental way to make a pipe turn, letting these complex networks weave around any obstacle in their path.
Second, you obviously have to connect two different pipes together. That's the job of the union, this little guy right here. It's designed to create this incredibly strong, leak-proof seal that basically turns two separate pipes into one single continuous tube. And third, and this one is critical, you have to have control. That's what a valve is for, like this ball valve. Think of it like the light switch and the dimmer for the whole system. It gives operators the precise ability to start, stop, or just fine-tune the flow of whatever is inside.
Now, here's where it gets really interesting. Once engineers mastered those basic jobs, they started specializing. Seriously, for almost any unique problem you can think of in piping, there is a specialized fitting designed specifically to solve it. It's like a whole arsenal of engineering solutions.
Let me show you what I mean. We'll start with this, the standard union. Its job is simple but essential. Connect two pipes that are the exact same size. Straightforward, effective. Does the job perfectly. But what happens if your pipes aren't the same size? No problem at all. That's exactly what this, the reducing union, is for. It's brilliantly designed to adapt the connection, letting you seamlessly join a big pipe to a smaller one without losing any strength.
And what about a super specific problem, like needing to run a pipe clean through a solid wall or a steel plate? Yep, there's a part for that too. This is the bulkhead union. It's made not just to connect pipes, but to pass right through a barrier and lock itself in securely on both sides. Pretty cool, huh? And honestly, this just keeps going. This specialization is incredible. There are fittings to split one pipe's flow into 2, 3, or even more paths. There are fittings made to branch a smaller line off a huge main one, fittings to adapt between different kinds of threads, and of course, simple fittings just to seal off the end of a pipe. The variety is just mind-boggling.
So, this all leads to a really crucial question. With all this insane pressure and all these potentially dangerous materials flying around, how can we actually trust these little components? Well, the answer is all about what they're made of and the incredible quality that goes into making them.
So yeah, how do we trust them? It's because their production is governed by these incredibly strict international standards. A certification like this one, ISO 9001, it's not just some piece of paper. It's a guarantee. It's a guarantee of quality control, of materials testing, of absolute reliability. It's a promise that every single one of these fittings will do exactly what it's supposed to do every single time.
And this table here really shows you the science behind that promise. The material for each fitting is chosen for its own unique superpower.
You've got stainless steel, which is the absolute champion against corrosion and rust. Carbon steel is for when you just need raw, brute strength for high-pressure jobs. Alloy steels are engineered to handle the most extreme temperatures and pressures. And for the nastiest chemical environments, you bring in the big guns, specialty alloys like Monel or Inconel.
So, how does all this come together to actually connect our modern world? Now that we kind of get what these fittings are and why they're so reliable, we can start to see their impact everywhere we look, often hiding in plain sight.
For example, take the food and beverage industry. Here, hygiene is absolutely everything. You need fittings that are perfectly smooth, with no cracks or crevices where bacteria can hide, and they have to be super easy to sterilize. That's why they use this, a special triclover fitting. Its design makes sure that the milk or juice or medicine flowing through it stays completely pure.
Now, let's do a complete 180 and look at a petrochemical refinery. Here, the challenge isn't hygiene, it's holding back immense pressure and containing volatile chemicals. So you need something incredibly tough, like this rugged forged steel elbow. This is the kind of heavy-duty part that keeps a high-pressure system totally stable, letting us safely produce the fuel that powers our world.
And if you want to see this on a truly massive scale, look at something like shipbuilding. Here, the fittings literally become a permanent part of the structure. Take a look at these big butt weld fittings. They aren't just screwed on, they're actually welded into place, becoming the actual joints that hold together the steel skeletons of ships and other huge infrastructure projects.
So, from the food we eat to the energy we use, these tiny hidden heroes are the critical connection point for almost everything. They're a perfect example of the kind of unseen engineering that just makes modern life work. And it kind of leaves you with a question, right? What other invisible components are out there quietly shaping the world all around you?